A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So far in the previous classes, we discussed about the various types of the boilers like water tube boiler, fire tube boiler, and similarly, what are the various types of the boiler mountings are there and boiler accessories are there. What are the various functions of the superheater, economizer, air preheater. So like that we discussed about the various types of the boiler mountings as well as the accessories. So in the today's classroom discussion topic is performance of the boilers and equivalent evaporation, boiler efficiency and boiler trial. So what is the motivation towards this particular class? So it is very essential to know the performance parameters of a boiler to assess the performance of a boiler. So the outcome of the today's lecture is, after completion of this lecture, I am expecting every one of you should be in a position to estimate the performance of a boiler. So now, how can you evaluate the performance of a boiler? That is important one. So there are various parameters are there by which you are able to evaluate the performance of a boiler. So here the performance of a boiler is calculated for comparing the boilers for its evaporating capacity, energy consumption and heat balance sheet. So the quantity of heat supplied to vaporize the water from and at 100 degrees centigrade and 1 atmosphere is referred as evaporation unit. That is, always we are able to compare the boilers of the similar capacity only we are able to compare. So that's why the performance evaluation of the boilers is normally represented by means of the various performance parameters. So here we are able to discuss about the first one. It is known as the evaporative capacity of the boilers. So how can we define the evaporative capacity of the boilers? So that is the quantity of the steam generated by the boiler at full load capacity is known as evaporative capacity. That is, the boiler is basically meant to produce the steam. So that is at full load condition, how much amount of the steam is generated by the boiler. So that is known as the evaporative capacity. So how can we find out the evaporation rate in kgs per hour and evaporation rate in kgs of the steam per hour and per meter square? And here the evaporation rate in kgs of the steam per kgs of the fuel, that is 19.27, 19.28 and 19.20. So here all these three will give you the brief introduction about how to calculate the evaporation rate in various units. So coming to the next one, that is how can we evaluate the equivalent evaporation? So how can we define the equivalent evaporation? So here the first paragraph is very important one. So the quantity of the steam generated by a boiler depends upon the four important factors. The first factor is known as the feed water temperature which is applied to the boiler. Next, working pressure of the boiler, the fuel which is used in the boiler for the combustion purpose, and the quality of the steam generated, that is whether it is the wet steam or dry steam or superheated steam. So here, how can we define the equivalent evaporation? It is defined as the amount of dry and saturated steam generated from feed water at 100 degrees centigrade at normal atmospheric pressure conditions is known as the equivalent evaporation. So that is very important one while you are calculating the performance capacity of the boiler. So that is how to calculate the superheated steam. That is here the H superheated, that is equivalent to Hg, that is nothing but H dry saturated steam plus, that is it is known as the degree of the superheat. So T superheated minus 2 saturated into the specific heat of the superheated vapor. So now here the evaporation per kg of the fuel is normally denoted by EMA, that is equivalent to mass of steam generated per hour by mass of fuel burned per hour, that is equivalent to m dot s by m dot f. That is the formula to calculate evaporation per kg of the fuel. Then how to calculate the total heat supplied to the water in the boiler means the m dot a into h minus hf1. So m dot a will be taken from the above equation, and here and the equivalent evaporation ME formula will become now MA into H minus HF1 divided by 2257. So this 2257 is nothing but the HFG value at 100 degrees centigrade, that is at which the feed water is supplied to the boiler. So always you have to remember this important equation, that is the 19.31, to calculate the equivalent evaporation capacity. So the units are kgs of steam per is the kgs of the fuel. So the next performance parameter here is the factor of evaporation. So the factor of evaporation is defined as the ratio of the heat received by 1 kg of the feed water for evaporation under actual working conditions to that received by 1 kg of water evaporated from and at 100 degrees centigrade. So it is denoted by Fe. So Fe is equivalent to H minus HF1 by 2257. So here the factor of evaporation can be defined as it is ME by MA. So already ME, MA already we calculated from the previous slide. So the important one is the performance of the boiler will be measured with the help of the boiler efficiency. So the boiler efficiency, how to calculate? So the boiler efficiency formula here is heat required to produce the steam from the feed water divided by heat liberated by burning of the fuel. That is simply it is output by input. So output from the boiler is the steam and input is nothing but we are burning the fuel. So how much amount of the fuel we are burning to produce the given quantity of the steam from the feed water. So that is nothing but m dot s into H minus HF1, that is equivalent to the numerator. So heat liberated by the burning of the fuel, that is the Q is equivalent to MF into CV. But here we know that m dot S by m dot F, that is equivalent to MA, that is the evaporation per kg of the fuel. So just you replace m dot S by mf with MA, so that the same formula will become MA into H minus HF by CV. So it is the formula to calculate the boiler efficiency. So the next one, the percentage of heat utilized in the superheater. Because we know that the superheater is a device or it is a boiler accessory which is used to increase the temperature of the steam. That is, we have to convert the dry saturated steam or the wet steam into the superheated steam before entering into the boiler. So with the help of the flue gases which are leaving from the boiler, we are able to heat the wet steam or the dry steam which is coming from the boiler. So here that's why the percentage of the heat utilized in the superheater. So in the numerator we are able to have heat utilized in the superheater divided by heat liberated by the combustion of the fuel. So the formula will become now the H superheated minus H by CV. So how to calculate the H superheated I already discussed. So it is the dry saturated enthalpy plus CPV into T superheated minus T saturated. So the next one is the economizer efficiency. So economizer efficiency is defined as it is the ratio of heat utilized in the economizer to the heat available of the flue gases. So once again we should know what is the function of the economizer. So that is we have to supply the water to the boiler. So the water is basically supplied to the boiler with the help of the economizer. Normally, the feed water will be supplied to the economizer. So this particular the feed water will be heated, further heated by the flue gases which are leaving through the boiler. That is, first of all, the flue gases will pass through the superheater. Next, it will pass through the economizer. So that's why whatever the amount of the heat energy there in the flue gases, so that will be absorbed by the water which is taken as the inlet to the economizer, so that the exit of the economizer we are able to have somewhat hot water. So that particular the hot water will be supplied to the boiler. So that's why the heat input to the boiler will be reduces. So that's why the efficiency of the power plant will be increases because of providing this particular the superheater, economizer as well as air preheater. So here the 19.36, it is the equation which is used to calculate the economizer efficiency. Next one, the 19.37 will give you the percentage of heat utilized in the economizer. So these are the formulas which are used to estimate the economizer efficiency. Then the overall efficiency of the boiler is given by the 19.39 equation, that is heat utilized in the boiler point divided by heat produced by the burning of the fuel. So that is simply it is output by input. So now, based on these particular important factors, now let us solve a problem on the boiler efficiency or the performance of the boiler. So just you go through the problem. A boiler generates 8 kgs of the steam per kg of the fuel burn. So first you write down the given data. So that is the MA, that is equivalent to 8 kgs of the steam per kgs of the fuel. So here you are able to have MA is equivalent to 8 kgs at a pressure of 12 bar from the feed water. So P is equivalent to 12 bar entering at 80 degrees centigrade. So the water is basically entering at 80 degrees centigrade. The boiler is 75% efficient. So the boiler efficiency is given as 75%. Factor evaporation, that is Fe is equivalent to 1.15, and here he has given that the specific heat of the superheated steam, it is equivalent to 2.3. So CPS or CPV is equivalent to 2.3 kilojoules per kg Kelvin. So this is the given data. So from which we have to calculate the degree of the superheat and the temperature of the steam generated and the calorific value of the fuel and equivalent evaporation in kgs of steam per kgs of the fuel. So here we know that what is the formula to calculate the factor of evaporation, that is equivalent to H minus HF1 by 2257. So here H is nothing but the superheated enthalpy. So that is nothing but Hg plus Cps into T superheated minus T saturated minus HF1. So go to the steam tables. So at the given 12 bar pressure, saturated temperature is equivalent to 188 and saturated vapor enthalpy is 2784, and at 80 degrees centigrade feed water temperature HF1 value is equivalent to 334.88. So here, so the formula will give you this particular one. So Hg value we know, so that is a 2784 plus Cpv we know, T superheated minus T saturated, that is we have to find out the degree of the superheat. The degree of the superheat is basically denoted by T superheated minus T saturated. So this one we have to find out. This one we have to find out. So all the variables are known to you except the degree of the superheat, so that we are able to know that it is 62.3 degrees centigrade. That is the first bit answer. So in the same thing, is also asking us to calculate the temperature of the steam generated. So the T superheated is equivalent to T saturated plus the degree of the superheat. So T saturated is equivalent to 188 plus 62.3, that is equivalent to 250.3 degrees centigrade. So that is the temperature of the superheated steam. So that is the A bit answer. Next, coming to the second bit, that is the calorific value of the fuel. So because we know that the boiler efficiency is already given in the problem. So boiler efficiency formula is MA into H minus HF1 by CV. MA value is also already given. So H value we calculated from the superheated steam. HF1, that is the feed water enthalpy. So now the only unknown is CV. So here the CV value can be obtained like this. So the last bit is equivalent evaporation. So write down the formula MA into H minus HF by 2257. So here you know all the values. The equivalent evaporation is nothing but 9.19 kg per kg of the fuel. So now let us go to the another problem. So in this particular problem is asking us to calculate the efficiency of the boiler, economizer and whole plant whenever the data is given about the boiler and economizer like this. So first, how to calculate the efficiency of the boiler. So because you know that the efficiency of the boiler formula is given by the heat utilized in the generation of the steam by heat produced by burning of the fuel. So how to calculate the numerator, that is nothing but m dot s into h minus hf, and m dot s he has given, that is the mass of the feed water is given as the 2060. So substitute here, and h value, that is the 2750, already he has given 2750 minus hf, because you know that hf is nothing but is the cp into t, that is the formula to calculate the hf, because you know that cp value of the water, because it is the water, so cp water is nothing but 4.187 into temperature. So the temperature is given as 105 degrees centigrade. So here he has given as 105 degrees centigrade. So now you get heat utilized in the generation of the steam, that is equivalent to so and so. Next, in the denominator, heat produced by the burning of the fuel, that is m dot f into cv. So that is a mass flow rate of the coal burnt, that is equal to 227 kgs per hour. So substitute here. Calorific value of the coal is also given 30,000, so that we are able to calculate the heat produced by complete burning of the fuel. So substitute here, so you are able to get the boiler efficiency is approximately 70%, that is equivalent to 69.88 percentage. Then the second bit is economizer efficiency. So here also you write down the economizer efficiency formula is equivalent to heat utilized in economizer divided by heat available of the flue gases. How to calculate the heat utilized in the economizer? So that is nothing but m dot s into CPW into delta T. So m dot s, 2060, CPW water 4.187, TF1, that is heat utilized to raise the temperature of the water from 15 degrees centigrade to 100 degrees centigrade, because the inlet to the economizer is 15 degrees centigrade, exit is 105 degrees centigrade, so that we are able to calculate the numerator is equivalent to so and so. Next one, heat available of the flue gases, that is flue gases means G, mg, cpg, delta T. So mg value is given as the 4075 kgs per hour, cpg 1.3, delta T, that is a tg minus ta 370 minus 18. So by substituting this, we are able to find out economizer efficiency is equal to 52.5. So the last bit, that is the overall efficiency of the plant, that is the heat utilized in the boiler plant by heat produced by the burning of the fuel, so that we are able to calculate it is equivalent to 81.28 percentage. So in the similar manner also you can solve the next problem also in the similar direction. So first of all you write down the given data. So by using the same empirical relationships. So first you calculate what is the value of the equivalent evaporation per kg of the coal. So that is equivalent to 9.02 kg per kg of the fuel with the same formulas. And the last bit is the thermal efficiency of the boiler without superheater and with superheater. Is there any difference? So that is without superheater, we are able to have 61.75 percentage. With superheater, we are able to have 67.46 percentage. So here, approximately, we are able to have the 6 percentage increase in the efficiency with using superheater. So that's why it is always desirable to employ superheater, economizer, and air preheater in the devices. So like this, we are able to solve some problems on the performance of the boiler. I hope you understood about the how to calculate the performance parameters of this particular the boiler, and similarly the boiler efficiency, superheater efficiency, economizer efficiency, and overall boiler efficiency. So thank you one and all for listening this important lecture on the performance of the boiler. Thank you.